Hello everybody. I'd like to welcome you to this session, this IMS session, last session of the day of this first day of the GS UK virtual conference. And this session is going to be on IMS OTMA, use of virtual storage. And we've got an esteemed IBM colleague, IBM, not colleague, an IBM advocate that's been, I would say, is probably if I said you're golden, I hope you know what I mean by that, which means very experienced. Steve Nathan to present this session. If you've got any questions you'd like to ask, then please feel free to fire away verbally. So just unmute yourself. And alternatively, if you want to do it via the chat, you can always post it in the chat as well. So just bear in mind, everybody, that this session is recorded. So just bear that in mind. So I'll hand you over to Steve. Okay, over to you, Steve.
Okay. Well, I'd say good morning, but it is for me, but it's probably afternoon for you, wherever you are. Welcome to the session. As you said, I can take questions, but I do have a lot to talk about. And you will be able to see these slides, and they were put together such hopefully that you could use this as reference material. So I will get started. I have a lot to cover. So starting with OTMA architecture. Well, what is OTMA? OTMA stands for Open Transaction Manager Access. It's way back, it started in IMS 5.1. And what it does, it uses the MVS cross-coupling facility known as XCF to send and receive messages and commands to and from OTMA clients. Okay, there's no TCP/IP, there's no VTAM. The clients don't have to be in the same LFAR as IMS because XCF works across the sysplex. So it's a way to get messages in and out of IMS. And the OTMA is just code that runs in the IMS control region. There are many OTMA clients. MQ has an OTMA client called the MQ IMS bridge. You put a message on a bridge queue and OTMA automatically sends it via OTMA to IMS and gets the reply back. If you have TCP/IP applications, you would use IMS Connect, which is our TCP/IP server. If you're running in DB2 in a store procedure and you want to send a message, it has an OTMA client called DSNA IMS. If you're running in WebSphere, then there's something called the WOLA, and you can send messages using the WebSphere optimized local adapter. And you can write your own OTMA client, and it's very difficult to do. We also have something called the OTMA callable interface for C and C++ programs, and that several customers have done that, and it's a nice way to become an OTMA client. This is just a picture. You can see the OTMA code running in the IMS control region, and it's just connected via XCF to all these OTMA clients. Now, what's on the other side of the OTMA client? IMS doesn't care. OTMA doesn't care. That's the client's responsibility. Okay, let's more on the architecture. If you know IMS, you know that the SCD, the Systems Contents Directory, is the main IMS control block, mapped by the ISCD macro. And that points almost everything in IMS. OTMA has its own main control block called the TSCD, OTMA SCD. There's the mapping macro, DFS TSCD, it is delivered. And there's a field in the SCD that just points to this TSCD. Okay. And then inside the TSCD, you're going to point to everything inside of OTMA, including all the members, where there's this TSCD IMS MPE address. and that points to the MTE, which you will soon see what is. So here's just an overall map. We'll be going through all of these in detail. But there's the member table entry and the member control block. There's one of those for each member, whether it's IMS Connect or MQ or whatever. And then underneath that, there are T-pipes. Each member has a number of T-pipes, and which we'll talk about what those are. And associated with each T-pipe are TIBs and QABs. So those are things that you'll get to know. So an MTE is a member table entry. There's one per member, and here's the mapping macro. There's also a member control block, and here's the mapping macro for that. Then there are T-pipes. We give you the mapping macro for that. There's TIBs and there's QABs. Okay, a TIB is a transaction instance block. You'll see what that is. And a QAB is a queue anchor block. And you can have multiple QABs if you want to. So a T member, an OTMA member, it's an OTMA client. It could be an IMS Connect data store. And there can be multiple data stores, multiple clients from one IMS Connect. It could be an NQQ manager represented by a storage class. I have another hour talk on that if you want to see it sometime. But there can only be one client from an NQQ manager. OTMA callable interface can be a client. And like I said, DB2 store procedures or vendors or roll your own. Each one of those is a T member. Now, a T-pipe, that's the OTMA equivalent of an L term. Input messages arrive on a T-pipe. When an OTMA client sends in a message, it says, this is the T-pipe I'm sending the message in. Commit mode 1 output messages are sent on the T-pipe. Commit mode 0 output messages are queued on a T-pipe. We'll talk about that shortly. Okay, the T-pipe names are specified by the OTMA client. They're not in any IMS sysgen. When a message comes in and the client says this is the T-pipe, OTMA creates the T-pipe control block. For IMS Connect, for commit mode 1 messages, the T-pipe name is actually the TCPI port, which got the input message. For IMS Connect, for commit mode 0, it's the IMS Connect client name. Therefore, you could have many, many, many T-pipes from IMS Connect. For MQ, there are 2 T-pipes per bridge queue. One for commit mode 0 messages and one for commit mode 1 messages. And in the MQ ZPARM, you specified a T-pipe prefix. So the T-pipe name is the 3-character prefix plus a 5-digit number. And if you're using MQ shared queues, it's a 2-byte prefix. So like I said, the control blocks are dynamically created by IMS. And the T-pipe name has to be unique only within a client. Multiple clients can use the same T-pipe name. We don't expect MQ to coordinate with IMS Connect. The only restriction is a T-pipe name cannot be the same as an IMS transaction code, because we check for the tran code before we check for the T-pipe. And there are 2 types of T-pipes. There are synchronized and non-synchronized. Synchronized T-pipes exchange sequence numbers and can be resynchronized across failures. If MQ crashes or IMS crashes, when they come up, they'll exchange these sequence numbers, and therefore you won't get duplicate messages and you won't lose messages. Empty synchronized T-pipes, those with no messages on them, will survive an IMS warm start, but are deleted during a cold start. Empty non-synchronized T-pipes will be deleted during IMS warm start. Okay. The only use of synchronized T-pipes is MQ, and only for commit mode 0 messages. IMS Connect only uses non-synchronized T-pipes. And the OTMA client, when it's sending in the message, says that this is synchronized or non-synchronized. But if you're creating asynchronous output, say going to MQ, and you want it to be on a synchronized T-pipe, you can do that. And I've listed here the ways to do that. If you're really interested in MQ and T-pipes, put in a request for my MQ IMS presentation. And this is just a picture showing that over here I have IMS Connect. I have multiple data stores. 2 of them are going to the same IMS in the same XCF group, and one is going to a different IMS in a different XCF group. But MQ can only talk to one IMS in one XCF group. What is a TIB? A TIB is a control block in OTMA, a transaction instance block, and it has 2 uses. It anchors each input message, and also it anchors the output for commit mode 1 IOPCB output messages. We'll talk about those. Now, if a commit mode 0 message comes in, we delete this TIB control block as soon as the input message is enqueued in the IMS message queue. For commit mode 1 messages, these TIBs aren't deleted until the IOPCB output has been sent. And we'll talk about this. You can have too many TIBs, and that can result in a flood condition. Okay. If you're using IMS conversational, the TIB is there for the life of the conversation. A QAB is a queue anchor block, and it anchors output messages. Commit mode 0 IOPCB output messages and asynchronous output messages. If you're doing alt PCB output or IOPCB output for something called send only messages, or if the client NACs an IOPCB output message, it'll go back on this asynchronous output queue. And there are 1 or 2 QABs per T member. MQ only has 1 QAB because we send asynchronous output out directly. IMS Connect and OTMACI have 2 QABs per T member. One is for the IOPCB output, which is always just sent, and one for asynchronous output. It's called the hold queue. And there the client has to ask for the asynchronous output. Also, there's something called MQABs, multiple resume T pipes. If you want to have a lot of clients all waiting on the same T pipe for asynchronous output, you could have up to 4,095 of them if you want. Of course, all this is going to use storage, as we will see. Okay, I got to spend 5 minutes on commit mode and sync level because that's always important when you're talking about OTMA and storage. We'll talk about sync level first. Sync level is specified by the OTMA client for each input message, but it determines how IOPCB output messages are sent and alt PCB output messages. Okay, and what it determines is the client going to acknowledge the output message or not? So on the input message, you say, I want or I do not want to send an ACK for the output message. If you send in a sync level 0 message, sync level none, then you're telling OTMA, just send the output message and I'm not going to ACK it or NACK it. If it's a sync level 1 message, sync level confirm, then the client has to send an ACK for the output message. If it's a commit mode 0 output message, now I'm going to dequeue it from the IMS message queue. If it's a commit mode 1 output message, now I'm going to go ahead and complete sync point. MQ always uses sync level 1. There's also something called sync level 2, sync level sync point. If you're going to do two-phase commit with IMS Connect and IMS and the IMS Connect client with RRS, but it's only supported by IMS Connect and the IMS TM resource adapter. I don't know any customer that's using this right now. Okay. This doesn't apply to OTMA acknowledging input messages. You can ask OTMA to acknowledge input messages, and MQ always does this, and IMS Connect does this sometimes. Commit mode is also specified by the OTMA client for each input message, and it determines how IOPCB output messages are sent. And if you've ever used APPC, it has the same commit modes. Commit mode 1 is called send then commit because that's the way it happens. IMS sends the IOPCB output and may wait for an ACK before sync point is complete. You're just about to do sync point, and OTMA says, is there a commit mode 1 message from the IOPCB? Yes, I'm going to send out the message right now, and I'm not going to start sync point. Now, if it's sync level none, OTMA knows there is no ACK coming back, and it sends out the message and goes right into sync point. If it's sync level 1, it's going to send the message out, but sync point is not going to start until the client ACKs that message. And if it's sync level sync point, then it's got to wait for the ACK and RRS to tell it. Okay. So this may increase region occupancy because we're waiting for the ACK before we can do sync point. MQ calls these synchronous messages. The output messages are not queued. They're anchored on the control block. They're anchored on the TIB. And if you look at an IMS 03 log record and you look at the message destination name, you see a hex value, fox, dog, fox, 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 and then something that looks like an address because it is an address. It's the address of a CLB control block for that message. Okay. Now, if we try and send that message and we can't because, say, the client's gone away or there's something wrong, then that transaction is going to back out on a user 119 append. Okay. We haven't started sync point yet. We try and send the message. If we can't send it, or if the client NACs it, you're going to get a user 119 append and the whole transaction is going to back out. If you're using conversational transactions or FastPath EMH IFP messages, they must be commit mode 1. Now, just because we sent the commit mode 1 message out and the client has ACKed it, that doesn't mean the client can use it, because what if sync point fails? What if we're using DB2 and we go to do sync point and DB2 comes back and says, I can't commit? So what happens is that after sync point, OTMA will send another message out to the OTMA client, either a commit confirm or commit abort, which says, did sync point work or did sync point not work? Or it's also called a deallocate confirm or deallocate abort. So if sync point did not complete successfully, then the OTMA client should discard this output message. Okay. Now I've got a 1 hour presentation that just covers these flows. And again, if you request this, I'd be glad to give it to you, either through the conference or privately if you want. Just send me an email. Okay, these messages are non-recoverable on IMS. If they have not been processed and IMS is restarted, they're gone. It could be a cold start, a warm start, emergency restart. They're non-recoverable. Now, sometimes commit mode 1 input messages can generate commit mode 0 output messages if you're doing the program-to-program message switches. That is another 1 hour presentation. And commit mode 1 input messages are always treated as response mode, even if the transaction is non-response. And you can also set a flag that says, I want commit mode 0 input messages to work the same way if they're coming from OTMA. Commit mode 1 messages, output messages are only one message. If you do insert purge to the IOPCB, you're not going to get 2 1-segment messages. You're going to get 1 2-segment message. The purge is ignored. And you can also request that CM0 messages are treated the same way. Commit mode 0 is called commit then send. The output is queued and we send it after sync point is complete. It's queued on the QAB. The destination name is Fox, Easy Fox Fox, and the CLB address. And it always requires an ACT to dequeue it. And all PCB output messages are also commit mode 0. Okay, MQs call these asynchronous. Now we're actually getting to the topic. But that other stuff you really have to know to understand what I'm saying. Okay. So we got to know how OTMA uses virtual storage. I'm going to show you that. And we've got to control it. Now, there is some fixed storage before I even get into all the little details. There's some modules that we load into private, ePrivate, and ECSA. And I've just listed the size here. Not a worry. Now, OTMA has something called flood control because we don't trust OTMA clients and they can do things that totally fill up IMS control region storage and cause IMS to crash. And you can control flood at the OTMA level or at the team member level, the client level. We can control descriptors, SAPs, ACEEs, T-pipes, and TIBs. There is a member descriptor called DFS OTMA, and that's where you specify the OTMA level. And then for the team members, you can specify it at the member descriptor. And there's some commands. So here's a big picture. We're going to start at the top. Okay. For each instance of OTMA, there's a C pool, which that's where all the XCF messages arrive. There's a restart TIB hash. It's not very big. There's a member table. Excuse me. There are destination descriptors. Okay. There's member descriptors. There's a user ID hash. That's for ACEEs and a user ID table. Okay. And we'll talk about the storage for those. Okay. The TSCD is only 784 bytes in ECSA. The member table is only 12K, but each member has 40K in ECSA. Okay, we'll talk about that. And then there's the member control block. So this is just at the very, very highest level. If you're looking at a dump, and you use the IMS dump formatter, which I highly recommend. This is what a TSCD is going to look like. And you can see in red there, I've marked where you can find the descriptor tables and the member tables if you ever want to look at them in a dump. Plus lots of other good stuff. This is what the member header table looks like. It's very small. This is what a member table entry looks like. We've got some flags. This is for the OTMA, the server NPE, and this is for like IMS Connect, for all the members have an NPE. It's got a lot of flags on it. And again, the dump formatter shows you what all those flags mean. And this is what an MCB looks like. If you're really analyzing a dump, there's a lot of good stuff in here you want to look at. Okay. Descriptors. These are control cards in the DFS YDT proc line member. You can specify things about a member. You can specify things about a destination. The client descriptors are only 56 bytes and they're in ECSA. And the destination descriptors are 268 bytes and they're in ECSA. But on the DFS OTMA proc line member, you can specify the maximum number for each one of these if you don't want storage to be filled with descriptors. Okay. OTMA stores ACEEs. We cache the ACEEs, the RACF ACEEs for the user IDs, so we don't have to go back to RACF every time. Okay. And we store these. We have a hash table to find them, and then we have the actual member, the actual entries. Okay. And then you can specify how long they should remain in the cache before they time out. Okay. So you can specify what the maximum number of ACE is in that cache. Okay. There's the ACE USR member and the DFS OTMA. And then you can specify, well, there's a lot of different parameters in here. You can specify you want to cache them. The default is 30,000. It's best if you just take the defaults, but I'm not going to take the time now, but read through this foil if you're really interested. Okay. And this is the size of that. The default is you're going to get 720,000 bytes in ePrivate for the ACEEs and 12K bytes for the hash table. TCBs. OTMA has multiple TCBs. There's the control TCB. There's one for XCF to when we join and leave. If you're in a shared queue, we have a backend TCB. And then there's one TCB per T member. Okay, and each TCB has some storage associated with it. Okay. Some ZOS control blocks, some EPVT control blocks, and some ESA control blocks. I've listed them here. OTMA has subtasks called itasks or IMS tasks. This is how IMS does its own multitasking. But each iTask has storage associated with it. 240 bytes in ECSA, and either 4656 or 4376 bytes in ePrivate. And we're going to see which control blocks have which itasks. Okay. Now, each TCB has itasks. I've listed them here. Okay. Plus, there's two itasks for TIB for a T-pipe, one iTask for a TIB, one task for a QAB. So you can see if you have a lot of team members with a lot of T-pipes and a lot of TIBs, you're going to have a lot of itasks, and this storage is going to fill up quickly. So each member has a 168 byte member control block. It's got a 4,000 byte T-pipe hash, and it's got a 1,200 byte message hash. That's for each team member. Okay, there are also something called SAPs, save area prefixes. You can specify the number. The default is 18. I've never seen anybody use other than 18, and just take the default. I'm just documenting this here for completeness. Okay, each T-pipe has storage associated with it. There's a T-pipe control block, 688 bytes in extended private. There are 2 iTasks per T-pipe, okay, plus 1 or 2 quabs for per T-pipe, and these quabs have iTasks. Okay, so at the bottom you see you've got a T-pipe, you've got its 2 iTasks, okay, you've got a quab that's got its iTask, and you've got an async quab that's got it for IMS Connect, and if you have mquabs, you have multiple iTasks. Okay, that's a lot of storage. And this talks about the multiple resume T-pipes, if you're interested. Okay. And this also talks about multiple resume T-pipes. You can specify the maximum number. So we do try and clean up these T-pipes. Okay. At every checkpoint, OTMA will go out and say, is this T-pipe idle? It's not synchronized. There's no incomplete CM1. There's no key CM0. It's not stopped. It's not traced. All these things. And we will clean up idle T-pipes. OTMA does this very nicely. So that helps. Okay. And this says if it's idle for 3 checkpoints, then we'll clean it up. But there is an APAR that says we'll clean it up after only 2 checkpoints if that's what you want. Okay, called fast T-pipe cleanup. Okay. And it's called, the default is that we won't, but you can specify it in the DFS YDT proc line member. It was PE originally, but that has been fixed. Okay. This just shows a T-pipe control block. It happens to be commit mode 1, so the T-pipe name is the port number. Okay. So we're going to talk about flood control. And specifically for T-pipes and TIBs and AWEs. Also, OTMA will put out a message when it connects to a team member, and when it disconnects for a team member, you can use that for automation. Okay, I'm going to start with T-pipes. You can specify the maximum number of T-pipes per client and for all of OTMA. There's a max T-pipe MAXTP parameter on the member control card. Okay, there's no command. And you can specify from 200 to 99,999 or no limit. You also have these parameters, max TP warning, which says what percentage of the maximum when I hit that to when I put out a warning message. There's the max TP relief that says once I've gotten down to this number of T-pipes, now flood control is relieved. And it says, do I count back-end T-pipes at a shared queue? Now, I got here a link to the IMS documentation, which covers this in much more detail. Okay, when we hit the warning level, okay, we're going to put out this DFS 4382 warning message. When we hit the limit, we're going to put out the DFS 438 83 limit message. And then when it's relieved, we're going to put out this 4384 message. Okay. If we've hit the limit and somebody comes in and tries to create a T-pipe, we're going to NAC that input message. If we're talking about the global T-pipe flood limit, then these are the error messages that you're going to receive when we get the warning level, at the flood limit, and the when the flood is relieved. And again, we will NAC input messages. Now, there is something very tricky, which I'll cover very quickly. If you set a maximum T-pipe on the member level, but not at the OTMA level, then there's going to be a default global OTMA. And when that limit is reached, first of all, there's no warning. And when we reach the limit, we put out an error message, but we still allow T-pipes to come in. And so you still can have a flood. Okay. And we didn't like the way that worked. So we put out a new APAR, PH64647. And now we treat the default global like we did if it was specified. We put out a warning message, we put out a global message, we put out a flood relieved, and we will NAC messages if they try and create a T-pipe. I know I'm going fast, but I got a lot to cover, and again, it's all here for you. There's also something called a light T-pipe. If you're using IMS shared queues and we create a T-pipe in the back end, we don't need as much storage. And so you can specify, I want to use light T-pipe, but unfortunately the default is no. I recommend you always go in and set it to yes. Okay, now we've got input messages. And when an input message comes in, the first thing we do is create a TIB control block. Okay, 1,792 bytes in extended private. And we get a buffer out of the lump pool in extended private, and we stick the input message in there. And then we also create an iTask. 240 bytes in CSA, 5376 bytes in extended private for each input message. Okay. And I said here, the message in the lump pool will be freed when the message goes on the message queue. Each message has a TIB and an iTask. For commit mode 0 messages, that TIB and its iTask are freed as soon as we put the message on the message queue. But for commit mode 1 messages, that TIB is not freed until we send the IOPCB output. So if you send in 10,000 commit mode 1 messages for a transaction for which there is no NPR, I also now have 10,000 TIBs and 10,000 iTasks in IMS. Okay. Or if you have conversational, we don't release that TIB until the conversation ends. And can you trust your applications to clean up their conversations? I don't. Which is why we now have a default value in OTMA. We'll clean up stale conversations. Okay, FastPath EMH messages, their message go into an EMH buffer in CSA. Okay. And they may or may not go on the shared queue, depending on if they're local only, local first, global only. That's a FastPath parameter. And the maximum amount of CSA that you can use is specified in this parameter, and there's a link to it for its documentation. Okay, this is what a TIB control block looks like. It's got a lot of flags. And it's also got a byte trace, so you can see everything that TIB did. And so if it gets stuck, then we can see where we were in the processing of that TIB. Very, very handy. Okay. Sometimes before we can enqueue a message, we have to get the scheduler latch. And there have been times when somebody's gotten the scheduler latch and has not freed it. And in that case, you're going to get a lot of TIBs. Okay. And if it's requested an ACK and MQ hasn't acted yet, okay, we're going to get a lot of TIBs. We do have flood control for TIBs. We can specify it at the team member level, and we can specify it at the OTMA level. So in a team member, in the DFS YDT member descriptor, there's an INPT parameter, and you can specify the maximum number of TIBs. You can also change that value with a command. Or at client bid time, you can say this is the default number, and IMS Connect does this. If nobody does it, the default is 5,000. Okay. Now, let's talk about flood control. Okay. If you set a member limit and it gets to 80, 85, 90, and 95%, you're going to get this DFS 1988W message. If you hit the flood condition, then you get the DFS 89E message, and new messages that come in are NAC'd if they try and create a TIB. When it gets down to 50% of the flood level, okay, then you're going to get this DFS 0767I message. Or you can cheat and just increase the limit, and all of a sudden I'm not in flood stage anymore. Okay, I have 2 minutes. Oh, well, we're going to have to go quickly here. Okay, and then you can also specify it at the OTMA level on the DFS OTMA control card, or start team member all input, and the default is 10,000. And these are the messages that'll, when you hit 80%, when you reach the maximum, and when it's relieved. Okay. When we do hit flood condition, we do send messages out to the clients saying, stop sending input. MQ will stop. IMS Connect ignores the message. Okay. There's also AWEs. And these, if we get too many of those, this is the flood control. I've never seen that happen. Okay. Now, we do send flood degraded messages to IMS Connect. IMS Connect puts them in this table, and it'll the IMS Connect user message exit can look at this table and decide where to send messages based on this table. That's another whole talk. Now, there were a lot of messages. What I put here, okay, is a summary of all those error messages I just talked about, all on one page, just for your information, because otherwise I couldn't keep track. Output messages, there's one output message, one buffer in the lump pool for the output message, and is dequeued when the message is dequeued. Okay. They're all sync level 1 messages. We got to wait for an ACK before we dequeue them. Now, I talked a lot about this. And what I put together, and I'm going to show you in a second, I have a spreadsheet of all that storage I just talked about. We'll talk about it in a minute. But just a couple of other very quick points. OTMA checkpoints these things. It checkpoints T-pipes and quads, the TSED, the NPEs, and the TIVs, and the routing descriptors. So if you want to look to see those without taking an SVC dump, you can look at these checkpoint records. And the defects for these checkpoint records are documented in this macro. And as soon as you put on this APAR, you too can see that macro. Okay. We also checkpoint statistics. We have dispatcher statistics against OTMA team members. And there are now 2 new OTMA checkpoint statistics records. Okay, 45.1A and 45.1B. One's for global, one's for each team member. And we have the macros for those. And this is just what we checkpoint, just for your information. And IMS Connect. Normally, IMS Connect doesn't worry about virtual storage. But I've seen customers that send large output messages, and large has got to be in capitals, millions of bytes, thousands of segments. And there's an XCS send for each segment. And when they get into IMS Connect, it has to hold them all and then sort them in order. And I have seen 2 different customers fill up IMS Connect storage with XCF output messages. IMS Connect stores them in C pools, and the C pools fill up. So if you get IMS Connect, depending on out of storage conditions, you'll open up a case. I'm just going to turn around and yell at you and say, get your clients to stop sending these large messages. Okay, I made it within 2 minutes, which is not bad. Please, please, please turn in your session feedback. Okay, here is the little Q code thing to look at. Okay, and is it okay to take this down now, Mark? I can show one more thing.
Yeah, you can do another. You can show something else.
Let me figure how to stop sharing. Wait a second. Share. Where is the stop sharing? That's pretty tricky.
Well, it's the bottom. If you do at the bottom, you've got share, yeah. So it's not in your application. If you go down to the T,
I see a share box here.
yeah. But if you can go, if you've got options in the share bit right at the bottom of the tab. So within the Zoom application, yeah.
But all it says is share or a link to the slide.
Yeah. So click on the share at the bottom, and then you should be able to. Yeah. There's some options there next to the tab.
I don't see them. No, I'm sorry, I got the wrong thing there. Well, what if I just do this? Aha. Now, if I do screen share, so right now I'm not sharing anything, right?
Yes, correct.
Okay, and I want to share a window. And I want to do this. Go over here. Okay, just very quickly to show you, this is the spreadsheet that I'm putting together, which shows all of the storages in one place. Just for your information, I'll include it in the presentation and I'll upload it again to the conference. Okay?
Yeah, that'd be good.
Okay.
Can I just ask a quick question? It's on the,
please.
on the control, on the checkpoint records, you said there are extra checkpoint records that you can read, and then you have to add those in yourself, do you? So that you can read those.
Let me go right back to here again.
So I was just talking about you're saying you've got some DSECs for the actual checkpoint records, which you can add in. So that's something that your system program will have to add them in so you can look at them.
No, no, I think I'll show you what else. Oh, way at the bottom here. Okay. There are these checkpoint records. This is where I checkpoint the T pipes and the quads and things. Okay. And the macro is DFSYL40.
Okay.
It's OCO, which isn't nice. So I yelled, and there's this APAR, which is going to make it non-OCO, so you can go see those DSECs too. Okay. Now, these two, the 45.1A and the 45.1B, the DSECs are here, DFSL 45.1A and 45.1B. Those have been non-OCO from the start. So you can see those DSECs today. Okay. Does that answer your question?
Yes, it does, Steve. Thanks.
Okay. Yeah. Yeah. It was actually, you can thank Graham from BMC who yelled at me to get these DSECs out.
Okay.
So I know there's BMC people on the call. So thank you, BMC. Okay.
And it's there's $1 million question, is this, but because there is so much storage there, and depending on how many clients you have, how many, and the type of client and everything, then is it actually quite tricky to actually set up your systems so that you have the okay storage not running away with it, and you've got all of your particular parameters set. So you've got flood control, because there's quite a few, you've mentioned about flood control having different, you could do a whole presentation on that really. So I presume it is quite tricky for big systems to get this all under control.
In one word, yes. Absolutely. Okay. I've had several cases, and I've spent a lot of time with customers getting this set up. And if customers need assistance in doing that, they can just open up a Salesforce case and we'll be glad to help them.
Yeah.
We'll get SVC dumps. We'll look at their configurations. We'll look at their storage, and we'll give them recommendations for setting up all these parameters.
Yeah.
Very glad to do that.
Okay, that's fantastic. And then you did say you've got some other presentations associated with this. So I'll just reiterate that, if anybody does want those, then we can obviously do them at further GSEs, or you said even you do a private one. So that's fantastic. So, so that's probably that's a wrap from me for the moment, just because of the time. That's all for other people. I think there might actually be another session for other people, but much appreciated that. And we'll get these slides will be available, and they've obviously been recorded as well. So much appreciate everyone's participation. And just for info, there was up to 13 people on that on this on this presentation today, so that was good. So much appreciated. You? No, that's good. Yeah.
No, say, does that include you?
Yes, it does. But I'm an active participant.
I was going to steal another one. Okay, thanks a lot. I appreciate your help.
And thank you very much for your time and efforts today, and everybody else that's had to join these sessions today. And look forward to some sessions tomorrow and the day after. Appreciate it.